Let me share my screen quickly. Today, you can also see that in the call are Mark and Nemo, my coworkers. They joined the team about a little bit over a month ago, and you're going to see them more and more in meetups, videos, and like conference in the next couple of months. If you have any questions specific to them, you can ask them right after the talk in our Q&A. Do you see my slides now? Oops.
Yeah, it's see.
Okay, great. So today, my name is Minko Gechev. I'm working at the Angular team at Google. Today, I'm going to keep my presentation actually short. We're going to talk about the internals of the Angular CLI. But since there were a couple of new things that we shipped over the past weeks, which is our Angular roadmap and also our first public RFC about the Angular linker, I will leave quite some time at the end so that we can discuss these topics as well. A couple of words about me. So I've been doing open source for quite some time now. I've been shipping different open source projects for the past over 7-8 years, I would say. At a certain point, I realized that my GitHub contribution streak was actually showing some significant moments in my life. For example, when I joined Google, I wasn't very active because I was going through my very heavy onboarding process. My vacations are all over the GitHub contribution streak and so on and so forth. So a couple of the projects that I developed before I joined Google are Gechev, which is a tool for predictive prefetching for web applications that utilizes machine learning and data analytics so that it can provide faster navigation experiences to your users. Also, the Golinter Revive, Coalizer, and I think over like a couple of dozens of more. I believe most of you are already familiar with what Angular is, but still, let me give you a very quick overview about the stack that we provide. In general, we're building an integrated platform for development of web applications. And in the foundation of this platform is the framework. This is pretty much Angular core. It provides a lot of different features for content projection, dependency injection. It provides you primitives to develop and compose components together so that you can build an advanced UI and so on and so forth. On top of that, we also have the Angular tooling team that is working on different tools, including the Angular CLI. We have also the Angular components team that is working on the CDK, the component development kit, and also Angular material. On top of that, we have a collection of other tools. For example, we have internationalization, which is built into the framework that provides you a good way to build websites with multiple languages in a very efficient way that is optimized particularly for Angular, so that you have zero runtime overhead with the internationalization. You can expect more content about that in the next couple of weeks. We have a language service router and so much more. Today, we're going to focus particularly on the CLI. And we're actually going to look at a particular vertical for the CLI because it is a pretty large tool. Recently, it got quite popular, not only in the Angular community, but actually in many other different communities as well. Narwhal are building NX, which steps on top of the Angular CLI, and they're providing integrations for a variety of different frameworks, including Vue, React, and since recently, they're even building Go projects with the Angular CLI, which is pretty cool. I bet most of you have already used the CLI, but let me just show you how quickly you can get your project up and running, add server-side rendering, and deploy it to production in a couple of commands. So to create a new project, you just run ng-new, specify the project name, and this is going to bootstrap your project. It is going to scaffold it and install your modules. Here, for example, we want to add server-side rendering so that we can have a very fast, largest contentful paint for our application. When we add the Universal Express engine, this is going to provide integration with our server-side rendering infrastructure, and right after that, we can add our Firebase support with ng-add Angular/Fire. ng-add is a way to add a package and also invoke its functionality so that it can integrate into our project. You can see that Firebase here allowed us to select a Firebase project we can deploy our app to. Finally, here we're running ng-deploy. This is going to build our application by following the best practices for producing the production assets. And finally, it is going to deploy the application to Firebase hosting, where it is going to place our static assets. And it is going to deploy our universal part of the application to a Firebase function. Now, our application is live. So in order to see that it was actually server-side rendered, we can view the source. So originally, I was planning showing you this entire pipeline, starting with ng-new, and right after that, scaffolding the application, explaining how the schematics work under the hood, and digging deeper into implementation details for our builders and so on and so forth. But now I decided to focus on a particular vertical. So we're going to look at the build process and see what optimizations we are doing under the hood. There's a couple of things I wanted to mention about the CLI before that. A couple of our guiding principles there is that we want to build the tool to be very highly encapsulated. This means that we're hiding implementation details. If you have been using Angular for over 3-4 years, you probably remember that previously we had a command called ngeject that allows you to take the Webpack configuration for the Angular CLI and output it onto the disk. The problem with this was that from this moment on, you were pretty much by your own. You had to maintain your build configuration yourself, and you weren't able to get advantage of the improvements that we're constantly making in the Angular build pipeline. So now we dropped this functionality so that we can constantly ship tiny improvements over patch releases even, that are bringing to some significant, actually, savings in terms of bundle size and like tree shaking, dead-code-elimination, and so much more. This way, we can also very easily update your application, because if we know what is the structure of your app, if we know where exactly your configuration files are and what are the different values in these configuration files of the individual fields, we can very easily run a migration script that not only updates your Angular application to the latest version of the framework, but also updates your configuration so that you can stay up to date with the latest trends in the front-end development. At the same time, though, we know that we cannot cover 100% of the use cases for developers by having such an unopinionated approach. So that is why we have some extension points where you can plug some custom scaffolding logic. For example, you can bootstrap your project with custom schematics. You can specify a collection, and when you run ng-new, you're going to get a different file structure on the disk. You can override a command implementation, so you can pretty much implement your own end-to-end testing command, let's say, by using Cypress instead of Protractor. And there are many community packages that provide this. Or you can even overwrite your build process by completely overriding your build command, or just by altering the build configuration with tools such as ngx build plus. As a disclaimer, you don't really need to know anything of what I'm going to present from now on. It is just mostly so that you can have a good understanding of what we're doing under the hood so that we can provide you with a more efficient production version of your application. So again, such layered diagram for this Angular CLI this time. So we have the Angular CLI, which doesn't provide much by itself. It just exposes a global binary called ng, and under the hood, it provides basically a facade for many other different packages that communicate together. For example, we have the Angular builders. The builders API provides a way for you to implement different commands for the Angular CLI. We have schematics. That is a way for you to transform the file structure of your project, map files, change their structure, and later on commit them onto the disk. On top of the builders, we have the Angular CLI jobs. This is very much an implementation detail. This pretty much provides abstractions for you to schedule jobs, to synchronize jobs, so that we can run different commands. For example, when we run ng-deploy, we can schedule different jobs for building your project and right after that deploying it to production. On the schematic sides, we have fullprints so that you can bootstrap or scaffold your project. This is the collection that you provide originally so that you can get your original file structure for your project. We have ng-add schematics. Probably you notice how I ng-added Angular Fire, which performs some transformations on top of my project so that it can integrate with it easier. And ng-update. This is another example of schematics, where just by running ng-update for a particular package, if this package has update schematics, we're first going to run it against your project so that we can make sure that it works with the latest version of the package. And right after that, we're also going to update the dependencies. On top of the jobs, a very key portion of it is Webpack. So generally, you shouldn't really worry about Webpack because this is a build tool that we have abstracted with the Angular CLI. We want to be ideally able to transparently completely replace Webpack with any other different bundler, for example, with Parso or Web or Rollup, if we decide to, and if it turns out to be a better idea. But that is what we're currently using. We're currently using Webpack, and we believe that this provides the most ergonomic and the most efficient in terms of development experience tool. On top of Webpack, we have TypeScript and Cursor. TypeScript is the TypeScript compiler, and Cursor is a JavaScript optimizer that can take a large JavaScript file and perform a bunch of different optimizations on top of it. We're going to look at Cursor in a little bit. On top of TypeScript, we also have the Angular compiler that takes your templates of your Angular components and transforms them to very efficient JavaScript instructions that can very efficiently render your components and also efficiently perform change detection with very low memory overhead. That's one of our principles for change detection. We want to make it fast and efficient with very low memory usage. That is why we spend so much time in optimizing Ivy as well. So yeah, today we're going to focus on the left portion of this Angular CLI story. We're going to focus on how we're building Angular applications. So when you want to build an Angular app, you generally use two different commands, for production or for development builds. Here, usually when you're building for production, you would also have to specify the prod build, the prod flag, but let us assume for a second that this flag was there. So if you want to build your application for production, you can run ng-run the name of your project, :build, and after that specify also the prod flag. This is pretty much equivalent to just having ng-build. We have this command alias that directly translates to ng-run the name of your project, :build. Once you run this command in the Angular CLI, the Angular CLI first is going to read your angular.json file so that it can find the actual implementation of the command. Once it performs this lookup on angular.json and it finds your project, and from there finds the actual command that we have invoked, and it discovers the implementation, internally we're going to require the builder associated with this command. The builder is just a function that has been exported from an npm module. That's pretty much all of it. Right after it, we're going to invoke the builder, and that's it. Once the builder has been executed, we're going to invoke the actual commands and perform the magic that this command implements. Today, we're going to talk about the browser builder that implements ng-build. It performs quite a few optimizations. So here, if you look at what it does for Angular I/O, you can find out that, well, compared to the development build, the prod flag decreases the bundle size about 10x. Although we can shrink it even further, this is a pretty good start, I would say. Now let us look at the actual compilation pipeline and plug into the individual steps of it so that we can get better understanding of the individual details and see how things are working under the hood. So first, when you run ng-build, we're going to run the Angular compiler, ngc. The Angular compiler is going to analyze your application. It is going to figure out which are the different directives, pipes, and components that you use inside of your Angular templates. And out of the templates, it is going to generate IV instructions. Right after that, we're going to compile this with the TypeScript compiler, since NGC is going to just generate a bunch of TypeScript files. Right after that, we're going to pass this JavaScript generated from the TypeScript compiler to our build optimizer that is going to perform some magic so that we can get final smaller bundles. We're going to pass this to Webpack so that it can chunk everything together into a couple of large bundles depending on your lazy loaded boundaries. Right after that, we're going to pass it to Cursor, the JavaScript optimizer. It is going to perform some tree shaking, dead-code elimination. It is going to perform mangling, so it is going to rename some of the variables that it can so that it can produce a smaller bundle. And finally, we're going to invoke the TypeScript compiler again, so that for your ES 2015 bundles, we can produce an ES5 equivalent and take advantage of differential loading. So if any of these terms is not yet familiar to you, we're going to look in depth in most of these steps. So we're going to explain these concepts further. I have actually omitted a couple of steps as well. On top of all this compilation pipeline, we also have the Angular compatibility compiler, so that we can allow your Angular IV applications to work with Vue engine libraries. These are legacy libraries that were built with our previous compilation pipeline called Vue engine. We also have internal serialization step, which takes your Angular application and it pretty much inlines different translations inside of your templates. And we have internal serialization extraction as well. So I have omitted these steps for pretty much simplicity, because talking about our internal serialization pipeline is yet another story that is probably going to be more appropriate for a separate talk. Let us first look into the Webpack portion of this flow. Let us see how Webpack works. So remember, Webpack operates on top of JavaScript files right here. It is going to perform bundling for our application. Here we have an index.js file, which has a declaration of a function called subtract. And it also imports the function add from utils. In utils, on the other hand, we have a subtract function as well, and also we have the declaration of the add function. So here we have this dependency. Index.js depends on utils.js. Webpack is going to take these two files together and is going to produce another file. Notice how this file is wrapped inside of an immediately invoked function expression. So we have this anonymous function that we're invoking immediately, and under its namespace, we have the declaration of the functions from utils.js and also from index.js. Notice the name collision here. We have subtract in both of these places. So what Webpack is going to do is analyze these two files, detect this name collision, and rename one of the colliding functions by prefixing it with the name of the module. And that's it. Now, everything that Webpack did here is just to put all our functions from these two modules under the same namespace. All right, as the next step, we're going to pass this output to Cursor, which is the JavaScript optimizer. As I mentioned, this performs some dead code elimination by using static code analysis. It does not understand module loading because it operates right after Webpack, which has already bundled our modules together. And it does some variety of optimizations. It is going to remove white spaces. It is going to remove comments. It can optimize even Boolean values. For example, false, it is going to represent it with true, I guess, is going to represent it with exclamation mark 0 and so on and so forth. At the dead code elimination portion is probably the most important and the most interesting one for us. So remember the bundle that we produced from Webpack. We had add subtract, index subtract, and the log statement under the same namespace. Here, Cursor can analyze the execution flow of this program and get rid of the functions that we're actually not using. Here it can understand that we're not using subtract, index subtract, and it can even perform partial evaluation. So it is going to actually evaluate at build time at 1, 2, and it is going to produce the result out of it, which is 3. That's pretty impressive. So this is the actual tree shaking that Cursor performs. It is going to get rid of the pieces of, well, in our particular case, Angular that we're no longer using. There are some places there are some constructs which are harder for static analysis than the others. So not everything is obvious as this example. And that is why we're doing some further optimizations by annotating different constructs as pure. Let us look at an example. So here we have the function getData, which invokes local storage.get. It should be local storage.get item with a particular key. So when we invoke the getData function and we pass this thing to Cursor, what Cursor is going to do, without further knowledge about our program, is just to take the body of our function, get rid of the function declaration, and, well, inline it so that it can perform some kind of compression in this particular case. But in general, like, we are not really performing any side effects here. So whether we're going to invoke local storage.get or not, well, it's not going to make a big of a difference for our users at all. So since we're not performing any side effects, we can mark our getData invocation as pure. This means that we're not performing any side effects here, so that if we're not using the result out of the function invocation, we can directly get rid of it. When we annotate this construct here as pure, Cursor is going to produce an empty output. So this is actually what our build optimizer does. It analyzes your component structure, it analyzes your application, and it makes some assumptions about your Angular components so that we can get rid of them and tree shake them if you're not using them anywhere, if you're not referencing them, since we're not performing any side effects in our component metadata decorator, so that, well, we can easily get rid of them without creating any issues for your final production bundles. So this is the build optimizer. Now let us go back to the beginning of the compilation pipeline. Here is our Angular compiler. We're going to look at its Ivy version because it is simpler and, well, it is actually what I hope you're already using today. The Ivy compiler is going to take all your TypeScript Angular components and, well, it is going to perform, together with the TypeScript compiler, a transformation. So first, it is going to generate a bunch of TypeScript, and right after that, with the TypeScript compiler, we're going to down-level this to JavaScript. And the output of all of this is going to be just app.component.js, which contains this exact component that you have declared, together with the Ivy instructions that are associated with your templates. And it is also going to produce a DTS file that contains the TypeScript type definitions together with some Ivy metadata. To look at the actual template instructions that the Angular compiler generates, let us take a look at this example here. Notice how for our template, we're generating, which is a span, we're generating a template function. This template function has two different modes. One is a creation mode and the other one is an update mode. In the creation mode, we're going to have instructions for rendering the span and for rendering the ngIf directive. In the update mode, we're going to have special logic that handles changes in the condition of the ngIf directive here so that we can conditionally show the span element or not. And notice how we are referencing the ngIf directive in this directives array right here at the bottom of the file. This allows us to perform tree shaking. So when Webpack merges our application and Angular under the same namespace, we're going to reference all the directives from Angular that we're using in our components so that Cursor can get rid of the pieces of the framework that we're no longer using and that are not relevant for our application. Well, we also brought some improvements with the Ivy compilation pipeline. So here you can see how the Ivy components compare to the ng factories that we were generating before. And the baseline is the HTML template. So, well, the Ivy template instructions, they're more verbose than the HTML template itself. Maybe they're about like twice the size of the HTML template. It mostly depends on how many bindings you have in your app. But Ivy by itself is, I would say, about 10 to maybe over 50% more compact compared to the Vue engine factories that we used to generate before we introduced Ivy. I already shared with you mostly what the build optimizer does, but let us look at a specific example. So here, if we assume that we have our Angular components, here I have dropped the component decorator for simplicity mostly. Cursor is going to take this input and it is going to output something like this. It is going to remove the name of the component since we're not referencing it anywhere, and it is going to inline the property declaration. However, what we're going to do with the build optimizer is to annotate this component as pure, so that Cursor can get rid of it entirely if we're not using it in our final application. All right, and the final part is how we're down-leveling scripts from ES 2015 to ES5. This is the so-called differential loading. The differential loading we introduced in the Angular CLI in version 8 so that we can make your application smaller. And this was one of the examples why we want the Angular CLI to provide such an encapsulated build, because we were able to introduce this feature completely transparently for developers. You were able to just update from Angular version 7 to version 8. And, well, you got by default smaller bundles for users that are on your browsers. Differential loading is a way for us to produce two different builds of your application. We're producing ES5 builds with like ECMAScript 5 for older browsers, and we're producing ES 2015 builds for newer browsers. The ES 2015 builds, they require fewer polyfills. So in general, we can reduce your bundle size dramatically just by not adding polyfills for different abstractions such as maps, sets, and other APIs that ES 2015 introduced. But on top of that, ES5 has also less expressive syntax. So even if we don't ship any of these polyfills, the ES 2015 bundles are still going to be smaller compared to ES5. And here is how much improvements we brought by introducing differential loading. So we dropped about 65 kilobytes of polyfills and from 2 to 10% improvements for your bundles overall because of the more expressive syntax. With differential loading, the way that we're loading your application is by referencing both the ES5 and the ES 2015 builds in different ways. So if you look at an application that is built with differential loading enabled, you're going to see that you have two different script tags, at least. You have a script tag for with type module that contains your ES 2015 bundle, and a script with an attribute no module. This is your ES5 application version. Browsers which support ES5 modules, they're going to download the script type module, and they're going to ignore the one with no module. And browsers which do not understand ES 2015 modules, which don't have ES 2015 support, they're going to download the no module script. Well, that was pretty much the entire build pipeline. just a very quick recap. So first, we go with ngC and the TypeScript compiler to produce, first, translate your templates to IV instructions, and right after that, down-level them to JavaScript. Webpack takes this JavaScript, it puts it into the same namespace by dealing with name collisions. We are annotating this JavaScript with our build optimizer so that we can annotate side effect-free constructs. And right after that, we're passing it to Cursor so that it can perform tree shaking and get rid of unused source code, as well as perform some transformations to make your application smaller. Right after that, we have an ES 2015 output that we just down level to ES5 for differential loading. And well, that's pretty much all of it. You can debug this build by using the ng build profiling environment variable. Setting it to true is going to output a profiler that you can import into Chrome DevTools and see how much time you spent in each one of these individual phases. If you want to see why your bundles are like big and why your initial load time is slow, what you could do is use a source map explorer. So you should first enable the source maps in your angular.json for your production build. And right after that, run source map explorer so that you can see how much JavaScript from the individual libraries, from the individual dependencies that you're using are taking most of your final production builds. And of course, something else that you could take advantage of is the source code coverage in Chrome DevTools. Here you can see how much of your JavaScript has been used during initial loading. And if most of it hasn't been used, then the best thing you could do is apply code splitting so that you can lazily load some functionality that the users are not consuming immediately. Well, that was it. The developer-facing API for like everything that we talked about so far is just ng-build --prot. Under the hood, we're doing all these optimizations that you shouldn't really care at all about because, well, they may change across patch versions because we're constantly trying to make the build smaller. This is, however, only possible because we can make some static assumptions on top of your project. We can analyze your application better because it has some type annotations coming from TypeScript. It has some predefined project structure that we understand with our tooling and we can transform and make better and optimize. And we also have this optimal internationalization pipeline that allows us to let you build applications with zero runtime overhead. That was everything from me. If you have any feedback, I would really appreciate it if you can fill the survey right here, mgv.io/talk. Thank you.
Okay, good. Thank you very much, Minko. So, as I said, I think we could combine both Q&A sessions that we wanted to do and questions about this talk. So, please vote and put questions in the surveys that I shared. And if you want to ask question with voice, raise your hand. So we will combine both. So, and also I wanted to tell that we have for our meetup also guests like Emma and Mark, who also, as far as I understand, now from Angular core team, right? Okay, cool. So let's start probably with voice question, the most active participants. So as far as I understand, Roman wants to ask question, or it's just it's different emojis. So I see clear hand from Aristides. So please. Yes.
Hello. Hi, can I ask my question?
Sure, yeah.
Yeah. First of all, thanks very much, Minko, for your presentation. It in Lightning. I'm a bit confused about the builders with Angular CLI. I mean, when do we use them? Do we use them only to build our Angular application? Because in my case, we have two applications. We have an Angular application and an Electron.js application. So when I want to build both of them, what I do, as I will show also in my talk, which is next, I do ng-build for the Angular application, and I have created a custom Webpack configuration, and I execute Webpack with this configuration for the Electron. And I put them, all of them, in the same folder. So, and I was wondering, should I create a builder just to build my Electron application? Or not? Thanks.
Yeah. Well, with the builders, you can pretty much create a command that can execute some piece of logic with the Angular CLI directly. I think their name is a little bit confusing because they're called builders, so you assume that they're used for building the application. They can be also used for deploying your application or even running tests. For the Electron scenario, I have seen a couple of packages from the community. One of the projects developed a builder for, like, you just replace the ng-build implementation of an Angular CLI project with a particular builder that allows you to build an Angular application. So it replaced our browser builder, the thing that I talked about today, with something completely custom that plugs into that plugs Electron into that. An alternative is to create a new command, which could be called, let's say, you can, let's say, ng run the name of your application colon build Electron maybe, and this will still allow you to execute the build process by using the Angular CLI. I'll say that the Angular CLI builders, they're primarily useful for you to create a command that you can invoke with the Angular CLI. That's pretty much their entire purpose. They just allow you to extend the public API surface of your Angular CLI application. That's it.
So I don't gain a benefit as you described it for creating a builder for Electron. I just create a custom Webpack and that's it, isn't it? Yeah,
the only benefit you're going to get is that you'll be able to build your application by running ng-build, let's say, instead of running your custom Webpack script.
Right. Okay. All right. Thanks very much.
Okay, good. Yeah, we have quite a lot of questions. Let's start with there are some like technical questions, some general one about Angular. First one, how can I analyze slow ng-serve recompile time?
Yeah, so with ng-serve, you might be able still to use this build profiling flag. I cannot guarantee that actually because I haven't tested this, but I would recommend first to try ng-build profiling and see whether this is going to work with ng-serve. If it doesn't, what I usually use is digging deep into my into the Angular CLI internals. I don't know if that's the most efficient way that you can approach things. That's my approach usually, just adding different markers, console.mark and console.markend, I believe, and seeing how much time you're spending in the individual phases. If you're spending a lot of time, the chances are that most of the time you'll be spending in TypeScript or Angular compilation. And this could be tricky really to analyze because internally the Angular CLI, in particular ngC, the Angular compiler, maintains a dependency graph across all of your Angular components. And when you make a change in your template, it tries to build the minimum amount of components that were impacted by this change. And depending on the change that you did, this could be more or less impactful. So generally, there is nothing much you could do to optimize the ng-serve process. This is mostly that the Angular compiler makes some assumptions about. There might be some low-hanging fruit. For example, if you have a really large SAS file, this could be causing some slowdowns. So I guess there are opportunities for optimization, but generally, my guess is that just your build graph could be probably really too big if your ng-surf is slow. So in such case, I would just recommend you to decompose your application into smaller libraries in a similar way that NX does, and just reduce your compilation size.
Okay, thank you. That was a question from Ilya. Next one. Why optimize JavaScript twice? Is it any way to do it once? I mean, step opt optimization probably and tensor.
It is once, yeah. First, we are bundling everything together. Right after that, we are translating, we are annotating it with our build optimizer. This is what opt was staying for. And right after that, we are down leveling it with tensor. So generally, it's only one optimization happening. We are not invoking the tensor more than once.
Okay, good. Next one.
Wait, one thing here. I wonder, Minko, is it because there is in the pipeline the TSC twice, the TypeScript compiler runs twice? So I think that's probably where the question is coming from.
I see. Yeah, in this case, so we are operating only on top of ES 2015 source code, so only on ES 6 output with ECMAScript 2015 modules. We are running TypeScript twice so that we can first compile this from TypeScript to JavaScript, and right after that, with the TypeScript compiler, we're just down leveling it so that this JavaScript is executable by older browsers which do not support the latest syntax. We're doing this compilation only once, and finally at the end of the build pipeline, we're just performing down leveling. I hope this answers the question.
Okay, thank you. Now I'm trying to triage questions to ask first, like questions about current presentation, and that was about yeah, this one. Will there be a way to extend configurations in Angular JSON file? I think there is already.
Yeah, you can extend the config in Angular.json. You can set different options directly in Angular.json, or you can extend your Webpack configuration by using a custom builder. In this case, NGX build plus the common solution. Yeah, that's already possible. I can send you resources for this.
Yeah, I think it would be convenient. And this is also a related question also from Ilya. What other builders are there for the Angular?
What other, oops, I think I said it twice. There are, well, we have builders for, again, like builders might be a little bit misleading because they're executing different operations, not only building applications. We're also linting. We have linting builder, which executes tslint, and in the future it is going to execute probably ESLint. We also have end-to-end testing builder, which executes protractor. We have something similar for Karma, and we have something similar for Webpack dev server that is responsible for handling ng-surf.
Okay, cool. And next one from Yuri. Can we utilize schematics to make changes across AST? For example, adding new input attributes to certain tags, or make some replace changes in RxJS chains?
Yeah, actually, there is a great link also in the chat about angularbuilders.dev. I didn't know about this website, so you can find some custom builders right there. Yeah, with schematics, you're able to perform transformations on top of multiple different ASTs. You can perform transformation on top of the TypeScript AST. You can also dig deeper into the template, and also the template, it has its own template expressions. So if you schematics, pretty much what it provides is just this in-memory file system, and from there you can use different parsers to parse files of different types and get different ASTs. So when you transform such AST, you can save it back into this in-memory file system, and schematics is going to commit it into the disk so that it can perform the actual transformation. And yeah, this is possible.
Okay, and one more for builds. Question from Ilya again. Custom build pipes based on internationalization. I11, I18, and question mark.
I'm not completely sure what do you mean here. If you can give more details in the chat, maybe.
You can extend your question or raise your hand via and ask it by voice, because I also not sure. What was it about? Okay, and that was all the questions about presentation. We can go through all Angular questions. There are two questions about roadmap. That's actually one, when and any plans, and that question was written before, or the one day probably before it was published. That was me. And another question about roadmap. Are there any estimates on Angular's roadmap in progress future section? Maybe at least some of them. Minko, you are muted.
Yeah, thanks. About the roadmap, it's actually our, not only public, but like our roadmap in general. There might be some small differences with what we currently have internally, only because since we started working on the public, what we publish on Angular IO, it's just required us to provide some more context for people so that we can explain what individual projects are all about. And there might be some small differences, but in general, that's what we are working on most of the time, like all the time. Yeah, it has been out for a while. About the future, providing estimates for some of the features, it's going to be hard. I would say that the ID library distribution is something that is going to happen very likely before version 11, because we already have the design, which is already in progress. We already had a lot of feedback from community folks. So we're probably going to implement this for version 11. For some other pressing features, such as TypeScript version 4 support, we're pretty much ready there. So there is nothing much that is holding us back. So this is probably going to land in version 11 as well. Webpack 5 is another thing that folks are excited about. This is mostly dependent on the Webpack team. We are waiting for them to release an RC or a final version before we are able to move forward and switch from Webpack version 4 to version 5 in the CLI. Also, I can share probably an update around the DevTools. I'm expecting us to share them publicly in the next, let's say, 2 months. We are doing some testing, some beta testing internally, so that we can make sure that we provide stable experience to people who are using Ivy. So this is something that you could be looking forward to, I guess, in the next couple of 8 to 10 weeks.
Okay, thank you. Next question is it possible to use WebAssembly in the future? Also not sure what is it about, but maybe you heard.
Yeah, I guess there could be different ways, either to have WebAssembly to perform some computationally intensive parts of the change detection maybe. I would say that this might not be very applicable for us at the moment, especially because of the cost for communication between JavaScript and WebAssembly that is going to pretty much be a larger bottleneck compared to what benefits it is going to provide. Maybe another point of view, like the question asked from a different perspective, could be whether we can use WebAssembly in our Angular projects. Yeah, I don't think we provide this out of the box right now, but it shouldn't be too hard to achieve this with a custom by plugging into the build process with NGX Build Plus. Definitely, if this is a highly demanded community request, like if many people are using WebAssembly with Angular, just feel free to open an issue on the Angular CLI, and we'll be happy to consider that as a feature.
Okay, good. Next one from Mikhail. Does Angular team have plans to remove Zone.js from dependencies?
Yeah, we're thinking of
asked a lot.
Yeah, we are thinking about that. So this is even on the roadmap. We have some very early exploration of that, how this can potentially look like, but it's not currently in progress. So we're looking into this. I cannot give more details right now about this because we don't have particular implementation plan yet.
Okay, thank you. Let's see what's left. Oh, I see Ilya extended his question about internationalization in this chat. I know that translation using localized function is a separate pipe. What about to make custom function like this one?
I don't know about this. I cannot comment on that, unfortunately. About localize, there we are currently aiming to provide a way for you to load translations at build time. I am not aware about pipes we have defined like that came up with the new localized function. So unfortunately, I cannot provide more details here.
Okay, and also again, internationalization question: is it possible to use one service worker for all progressive web apps for all internationalization bundles?
Yeah, this should be possible. There would be. It depends on what scope you use for the service worker. I guess by default, you should be able to use a single service worker for all your applications because I believe the scope is set to root. So it should be caching all the assets for all different translations of your applications.
Okay. Question from Alexander. Probably very general. How secure is it? Does Angular use certain protocol for security like JWT or anything else behind HTTPS? It's very broad.
Yeah, we're not opinionated about this. We are trying to the scope of Angular is to we're just trying to make sure that we are not opening any attack vectors for XSS or cross-site scripting attacks. That's why we have our custom trusted types implementation, and now we're working with the Google security team to implement trusted type support with the latest web platform APIs. But aside from that, we are not really opinionated about user authentication. I can share from my personal experience that JWT has been I have been successful with it. So I would definitely recommend that as a solution. Still, there are many variables there. You need to consider what you're using on the backend, whether you can afford to use a secure implementation that have passed audits, and so on and so forth.
Okay, good. And yeah, that probably all technical questions, and more question about Angular team. It's about some news that were shared, like that's something went wrong with Angular team. So there were some gossips about teammates were not treated well or so. Could you maybe say something about it, that
Sure,
everything is still fine.
Yeah, it's really hard for me to comment on this because this wasn't my experience, and it's really hard for me really to comment on this because really I have had completely different experience, and I haven't. It's hard for me to relate, but I'm sure that this critics has. I mean, I'm sure that there was something that the folks who commented on this were unsatisfied about. Since then, also there were a lot of different structural changes that happened on the team, and I joined during this transition, so that maybe that's the reason why I haven't noticed like anything, like I haven't been treated poorly myself. Yeah, we're trying to constantly do better in both like people management and building Angular itself. So I guess things are evolving over time, and I'm hoping that nobody else in the future is going to have a poor experience like working on Angular. That's the most I can share, unfortunately, since yeah, I haven't had this experience myself.
Can I jump in for a sec on this question? Is that okay? I just want to share from the experience of a new person to the team. I have had a very pleasant experience so far. The team is very welcoming, very supportive. It's a very good culture. Besides, I still work here. I mean, I would have quit if I didn't like it. So I'm having a good time, and I think it's a great place to work so far.